Okay, so we are doing a topic. The topic we are going to be looking at. Okay, we are going to be looking at forces. We say force. Okay, so now what are we supposed to understand under this topic? Okay, we are going to we need to define force, and force is defined as a pull or a push. So force is a a pull or a push. So now a pull can change the size or shape of a body. Both a pull and a push will change the size or shape of the body, or can change the motion of what? An object. If you are if a body is at rest, then you apply a certain force, you push that body, it's going to change, it's going to move. So that is the effect that the force is going to do, what that the force is going to have. So we have to define, we have to know to say force is a pull or a what? A push that will either change the motion of an object, or will change the size or shape of a what? Of a body. Now what is the SI unit for force? So we say the SI unit is Newton. That is the SI unit for what? For force, and it is a what? It is a vector quantity. Why are we saying it is a vector quantity? We are calling it a vector quantity because it is dealing with the direction and the magnitude, or size and direction. And we need to know to say weight is a kind of force. Weight is also a force. And then when we've looked at mass and weight, and you understand to say weight is also measured in newtons, and this force we're saying is measured in what? Newtons. That's why we are saying weight is a kind of a what? A force. So force can as well be measured by a spring balance, so as weight can. So you find that weight and force are both going to be measured by what? A spring balance, and they have the same SI what? Unit. Having understood that, we can move on to look at what resultant what? Resultant force. So what is resultant force? So this occurs if two or more forces act on an object. So for example, we have this object like that. We have 5 newtons, and we have 8 what? Newtons. So now where's the direction of the resultant force here? So the direction of the resultant force is going to be on that side where we have a greater what? A greater force. So if they are opposite like this, what you do is that to find the resultant, you're going to subtract. So you're going to say 8 minus 5. That is going to be, you subtract the what is the smaller force from the what? The bigger force. So 8 minus 5, that's going to be 3 what? Newtons. So our resultant is going to be this side. So you say the resultant is going to be in that direction. 3 what? Newtons. Why is it facing this direction? It's because the 8 Newton force is greater than the 5 Newton what? Force. So we can have another situation. We have, for example, this body like that. Then we have two forces. We have this force here and at force, then we have so then if they are in the same direction like that, you add them. So 4 plus that, so this body can be redrawn like this. These two forces are facing the same direction, so you can add them. That's going to be 9 what newtons. Then here is still going to be 11 newtons. Now the question can be, what is the direction of the resultant force here? So as I said, the direction of the resultant force will lie on the side where we have a greater what force. So this, since these two forces are opposite, so you subtract, you say 11 minus 9, so that's going to be 2 newtons. So the resultant force is going to be in this direction. So the 2 newtons is going to be in that direction. Okay, so now what if we have a body like that? So you have maybe 5 newtons and 4 plus 1 what newton. So these are in the facing the same direction. We add them, so the body can be redrawn like this. So 4 plus 1, that is going to be 5 what newtons. Even there it's 5 newtons. So to find the resultant, these are still opposite. You subtract. So you say 5 minus 5, 0. So this one, this 0 newton is indicating to say these forces are balanced on the what? On the object. These forces are balanced on the what? On the object. So having understood that, we can now move on to look at one man that has really contributed to this physics that we are all learning today, and his name is Newton. And this Newton explained this topic forces very well, and that's why you hear of Newton's laws of what motion. Okay, so what things are you supposed to know? You're just supposed to know what they can ask you. State the first law of Newton, the second law, or rather the third what? The third law. Okay, so let's look at these laws. What do they state? So we'll say Newton's laws. Newton's first law. So this one states that one, a body at rest will remain at rest and a body in motion will keep will continue being in motion at a constant speed. So what this law is trying to explain is that if you have a pencil, let me use this same pen that I'm using to write. If we put it like that, it's not moving, it will continue in that state. It will continue in that state. That is the first law of motion, of Newton's first law of what? Of motion. We are told to say if you have an object, it is in that state of rest, it will still continue to be in this state, provided I don't apply any force on it. If I lift it, then we are breaking the law of what? Motion. That's not Newton's first law. So we're saying a body at rest will continue at rest, and a body in motion will keep on in motion at a constant what? At a constant speed. Meaning, if you are running, you will continue to run, unless if a force is applied to you to either stop you from running. That's what this law is going to state. So under this first law of motion, we have this concept that you also have to understand: inertia. This is a property of a body to resist a change to its motion. So now inertia, so take note of this, inertia depends on mass of an object. So inertia is going to depend on mass of an object. An object with a higher mass who is said to have higher inertia. So we're saying inertia is a property of an object to resist a change to its what? Motion. We are told to say inertia depends on mass of what? An object. This can lead us to a question. I can ask you a simple question like, why is it easy to move a wire car or a truck? So you find that a truck has a higher mass. So it's going to have a higher resistance to change in its what? In its motion. If it's at rest, it will continue to be at rest. It has a higher what? It has a higher mass. Then a wire car has a low mass, so it's going to be easy for you to change its what? Its motion. You're going to easily move a wire car. Why? Because it has a low what? A low mass. So it has low inertia. But a big truck has a higher what? It has a higher mass. So that means it has a higher what? Inertia. It has it has high resistance to change in its what? In its motion. Okay. Having understood that, let's look at Newton's second law of motion. So Newton's second law. So this one states that unbalanced forces acting on a body produce acceleration in the direction of the force. Unbalanced forces acting on a body produce acceleration in the direction of the force. So what are we trying to say here? How do we explain this statement? So what this statement means is that acceleration is directly proportional to the force, and acceleration is inversely proportional to the what? To the mass. So I'm saying unbalanced forces acting on a body produce acceleration in the direction of the what? Force, meaning that acceleration is directly proportional to the force, and this acceleration is inversely proportional to the what? Mass, which brings us to a mathematical relation, which is acceleration is equals to force over mass. And from here we can say, from this relation that we've driven here, we can say, if we want to find the force there, okay, we can say force is equals to mass times acceleration by just multiplying the acceleration and the what? Mass. So these are the two important formulas that we're supposed to what? To know. Okay, let's move on. So I'm saying force is equals to mass times the acceleration, where m is the mass and it should be in kgs. Take note, mass should be in kgs. Then the acceleration, the a is, so saying a is the acceleration, and it should be in meters per second square, like that. So let's get an example to understand all this that we're talking about. Okay, so I told a force of 350 newtons acts on an object of mass 10 kg. Find its acceleration. Find its acceleration. So you're told a force of 350 newtons acts on an object of mass 10 kg. Find the acceleration. So as I always say, you first collect the data. We are told a force of 350 newtons. So force is equals to 350 newtons. And the mass m is 10 kg. The question is find its what? Acceleration. So we are told acceleration is directly proportional to the force and inversely proportional to the what? To the mass. This is the formula we're going to use to find the acceleration given the force and the mass. So acceleration is, what's the force? 350 newtons. What's the mass? 10 kg. So acceleration is 35 newton per kg, or 35 meters per square second. Then you're done. Let's get example 2. So we are saying a man pushes an 8 kg luggage on the smooth floor. It starts from rest and reaches 15 meters per second in 5 seconds. The first one is, what is the acceleration? So now you're wondering, you've heard of velocity in this question. So I told a man pushes an 8 kg luggage on the smooth floor. It starts from rest and reaches 15 meters per second in 5 what? Seconds. Now you are told to say what is the what? Acceleration. So now acceleration, I told you, says force over mass. This will not work. Why? Because in the question we're not given the what? Force. We are going to use this one. You remember from linear motion. These topics are just going to be interlinked. Final velocity minus initial. So we are told this object started from what? Rest. So the final is 15. Then since it started from rest, the initial is 0. The time is 5. So acceleration is 15 minus 0, that is 15, divided by 5, that's going to be 3 meters per square second, like that. So you have to analyze, what am I given in this question? Yes, you're given the mass, and you're given the what? You have velocity. Oh, acceleration is also related to velocity, but if you're given the force and the mass, use this one. Then the question that follows is that what is the force? So we know to say force is mass times acceleration. So force is, what's the mass? 8 kg. What is the acceleration? We said 3, what we just found, 3 meters per square second. So 8 times 3, that is going to be 24 newtons. That is the unit for force. So as easy as this. So first you look at the question, understand the question. What are they trying to ask? Try to look for, just understand that question, how they ask, and try to picture it and imagine you're going to be enjoying physics like that. So these are easy and direct questions. Okay, so what else are we supposed to talk about here? Else. Okay. Okay, I have to talk about the last part on this topic is we are going to talk about load and extension. So I was saying load and extension. So here, what is the load? What is the extension? The load can be the weight of an object. The extension is like the distance that you are going to move when you attach a certain spring, when you attach a certain load to a what? A spring. So to help us understand this, there is what is known as Hooke's law. Hooke's what? Hooke's law. So Hooke's law states that the extension of a loaded spring is directly proportional to the load, that is the force applied. So you are going to have this, and you have maybe a spring just there like that. Then maybe before attaching anything, it is maybe at 5 millimeter. And the second one is after attaching a load, it extends maybe here. Maybe this mass is, maybe we say 10 kg. We attach a 10 kg load. Sorry, 10 newtons. We attach 10 newtons. It extends from 5 maybe to 10 millimeter. So now, what things are we supposed to know? So we're supposed to know to say Hooke's law states that the extension of a loaded spring is directly proportional to the load force. So there's this relation where we say extension is directly proportional to the load force. And then we have another concept that we're supposed to. We're saying extension is directly proportional to the what? The load force. And here we're supposed to know to say we can have two or more. We can have more extensions and more loads there. So maybe on the same one, if we have to attach, maybe we attach maybe a 20 newton load, maybe it extends to 15 millimeter. So now this is all on the load and the extension. You know what Hooke's law states, and you understand to say we can have more extensions and more loads that are attached. So to understand Hooke's law, we use a spring. We use a what? A spring. So there is this formula to be using. We'll say extension 1 can be equal to the load 1 over extension 2 is going to be then extension 2 is equals to the load 2, like that. So this is the relation or formula that we're going. Let me write it properly. I'm saying extension 1 is equals to the load 1 over extension 2 is equals to the load 2. And this load that we're talking about is a force. Extension is a distance, the load is going to be a force. So now let's look at some questions that we're going to find under this load and the extension. So you'll be told example, a load of 4 newtons extends a spring by 10 millimeter. What load would extend it by 15 millimeter? So we have to imagine what they are talking about here. So we have this spring here, this spring, maybe just they have not attached anything. Then we're told after we attach now a 4 newtons load, so we come and attach a 4 newtons what load like that. Then it extends to what, to 10 4 newtons. So then it reaches from there to there, it now extends to 10 what millimeters. Now we are told to say, okay, what load, we are asking what load would extend it by 15 millimeters. So what load can we attach to this spring so that it extends to 15 millimeters? So saying what load we are asking, they're asking us to find a load that when attached to this spring to extend it to what, to 15 millimeter. So what formula are we going to use? We're going to use the same formula here. We'll say extension 1 is equals to load 1 over extension 2 is equals to what, load 2. So we have to identify which one is the extension 1 and which one is the load 1. So extension 1 are these, this part of the question that we are given. So extension 1 there is going to be equal to 10 what, 10 millimeter. Then the load 1 will be 4 newtons. The load is the force, extension is the distance. Then what else are we given? Now when we come to the next diagram here, we're only given the what, the extension 2. They're asking us to find it. So extension 2 is 15 millimeter. Then the load 2 is what we're asked to what, find. So you get this data and substitute in the formula. Extension 1, we're told it is 10 millimeter. Extension 2 is 15 millimeter. Then the load 1 is 4 newtons. Then we're looking for load what, 2. So what do we do here? We cross multiply. So loads 2 times that is going to have, we're going to have 10 L2, then 15 times 4, that is going to be 60. So to have the load 2, divide by 10, divide by 10. So then the load 2 is going to be 10 into 60, that's going to be 6 newtons. So a 6 newtons load would extend this spring by 15 what? 15 millimeters. And then there's one thing that I forgot to talk about in the introduction of this topic. So such topics, you find that they even bring it in section C, and you're going to be asked to create a graph to prove Hooke's law. So how we are told to say the extension is directly proportional to the what, to the load. So how would the graph appear? So I'm going to do a question using a graph on the same Hooke's law, since we already know the relation that is there. So what happens is that when we say that something is directly proportional to the other thing, we are going to be, the graph is going to be like this. And a graph is going to have the x-axis and the y-axis. On the y-axis, we're going to be having the extension, Then on the x-axis we're going to be having the load. So what would happen is that when we plot a graph, always it's going to come out like that. So when we say extension is directly proportional to the load, well, what we're trying to say is that when we increase the load, the extension also does what? Increases. When we reduce the load, the extension also does what? Will reduce. So this is what happens. I'm going to plot the graph. I've seen some questions in section C, and they're that easy. So this is what we're supposed to know on this. Maybe we do another example. Okay. Let's do another example. Example that we're going to have is that calculate the extension of a spring that would be produced by a 20 Newton load if a 15 Newton load extends the spring by 3 centimeter. So to calculate the extension of a spring that would be produced by a 20 Newton load if a 15 Newton load extends the spring by 3 centimeters. So what is happening here is this. So you have to imagine, so you have this. So this 15 Newton load will extend, so we have a spring. So it's extending the spring by 3 centimeter. Now I ask what extension of a spring would be produced when we attach a 20 when we attach a 20 Newton load. So same formula, extension 1 is equals to load 1 over extension 2 is equals to load 2. What is extension 1? The same 50. Extension 1 is the 3 centimeter, extension load 1 is 15 newtons. So let's just write it there. Extension 1 is 3 centimeter, then the load 1 is going to be 15 newtons. Extension 2 is what we are looking for, then load 2 is what we have, which is 20 newtons. So now extension 1, let's start substituting. Extension 1 is what? 3 centimeter over extension 2, that's what we're looking for, so just extension 2. Then the load 1 is 15, then the load 2 is 20 newtons, like that. So we cross multiply and just drive it from here. Let me create space here. So we are having 3 over extension 2 is equals to 15 over 20. So to have extension, we cross multiply. So that times that, we're going to have 15 extension 2. 3 times that, we're going to have 3 times 20. That's going to be 60. So divided by 15, divided by 15. So the extension 2 is 15 into that. 15 into 60. That is going to be 4 centimeter. So what we're trying to say is that an extension of 4 centimeter would be produced by a 20 Newton load. So as easy and simple as this. So this is the end of the topic forces. If you have any question, feel free to hit my inbox. Thank you.